free fall questions. Now, these questions are exactly the same as the questions we were just doing, the normal constant acceleration problems, except now our motion is vertical. We're going straight up and down. And when we're working with vertical motion on Earth, our acceleration is always gravity, which is negative 9.81. Okay, so when you're on Earth, the acceleration is always the same as g, which is negative 9.1. That negative is super important, and that means down. Okay, so that's got to be consistent for all of your equations. This also means our displacements are in the vertical direction, which means we can write our equations just slightly different. So for example, our holy grail, if we say delta x is equal to VIT plus 1/2 AT squared, how we can now write this as a free fall question, we can say delta y, or what I like to say is change in height, is equal to VIY, so our initial velocity in the y direction, plus 1/2 gt squared. This g, you can substitute that in. That's just your acceleration, but that's the idea. This is the same equation, you're just substituting in some values. Same thing with, say, this equation, v final is equal to v initial plus at. Well, still the same thing, but now this is going to be gravity times t, which is negative 9.81. Okay, exact same questions. You are just changing up how you write them. So we'll do an example. Okay, before that, I'm not going to give you these different ones with different letters in it. You just need to know how to use the general form of these equations. Know that if you're going in the vertical direction, then you're dealing with gravity and you're dealing with a change in height, not an x displacement. Okay. Another important thing with these questions is when you throw something up, uh, when you're moving up vertically, gravity's slowly trying to stop this thing and bring it down. So when you reach a maximum height, your vertical velocity is going to be exactly 0 for a split second. Now, if you ever think about trying to catch something from, like, let's say you're on a balcony or on a roof and somebody throws something up to you, if you think about trying to catch it right as it goes in front of your head, you'll notice it actually stops, or it looks like it slows down, because it is actually moving extremely slowly and then stops at that maximum height. So that is an important aspect, because we can break up these questions into an upwards motion and then a downwards motion. Okay, so let's do a couple examples. Just see how this works. We've got a bungee jumper jumping off a bridge, free falls for 2.2 seconds. We want to know the velocity after the free fall. So again, these questions are not going to tell you, but you always know the acceleration, negative 9.81 meters per second squared. Always know it. It's not going to tell you in the question, so it's important that you remember that you know it. And if we're jumping off a bridge, this means our initial velocity is going to be 0, and we're falling for 2.2 seconds, which means if we want to know what our final velocity is, we can use this equation here, plus AT. We know we're starting from rest. That's great. We know our acceleration. We know our time, negative 9.81, and we're accelerating like that for 2.2 seconds. So our final velocity is going to be negative 21.6 meters per second. The negative, super duper important that you don't lose that, because that means it's in the down direction. Don't lose the negative with gravity. It's got to be negative 9.81. Okay. Now, if we want to know how far they fell, remember I told you initial velocity is equal to 0. Use the Holy Grail. Well, this is exactly the same scenario. We want to know a distance traveled in the vertical direction, so we're going to get a change in height is equal to initial velocity in the y direction times time plus 1/2 AT squared. This is our beautiful Holy Grail. Our initial velocity is 0, so we're going to get a change in height being 1/2 AT squared. which is really nice because we know all that stuff. So if we go over here, we're going to look for this change in height, which is just going to be 1/2 times negative 9.81 times our time that we fell, 2.2 seconds squared, which means our change in height is going to be negative 23.7 meters. Now, at first that might not make too much sense to you because you're like, oh, well, how can a height be negative? Like what? Um, but remember that negative means down, okay? Your change in height is down. And what we can also do is we can look at this in terms of a change of height being our final height minus our initial height. So if our final height minus our initial height is negative 23.7 meters, well then that just means that if our final height is on the ground, this goes to 0 since we're on the ground, then our negative initial height is equal to negative 23.7 meters, so just our initial height was a positive 23.7 meters. You don't necessarily have to go through that step, but that's what that negative change in height means, is that we're actually falling down towards the ground. Okay. I hope you can see the similarity to these questions. I'm not going to do the rest of them. You can work through them yourself. We'll go over them in class, but they're exactly the same, except now you've got vertical direction, you've got an acceleration, which is gravity, negative 9.81. So go ahead, give those ones a try, and we'll go over the rest of them in class.